Okay, we're going to start at 10K because 10L is going to take a little bit longer here. Now, we talked about how ow is when we intersect on the outside. So we're going to utilize ow here. So this is outside times hole equals outside times hole. And let's start with the top line. What is the outside of the top line? So outside times hole equals outside times hole. What is the outside of the top line? Yeah, it's 18 units long outside. What's the whole length of that top line? Okay, be careful thinking that it's just going to be X. Okay? It's not just going to be X. It's going to be the whole length, which is X plus 18. Hi. Now, X plus 18 is the whole. Outside is, on the other line, what is the outside? So on the red line, we'll say. What's the outside? 23. What is the whole? 23 plus 25. Okay, so now we can do this pretty easily. Let's go ahead and distribute that through. There's actually a better way I'd prefer to do it, but I'm going to do it the way that you guys are used to. I would divide by 18 on both sides first, but let's just do this like you guys are used to. 18 times 18 is how much? 324. And 23 plus 25 is how much? Yeah, 48. So now I'm going to subtract 324 from both sides. And I'm going to get that 18x equals, what's 23 times 48? 1104. And subtract 324 from that. Is that 880? 780? Okay, 780. And then divide both sides by 18. What is 780 divided by 18? 130 over 3. All right, and I could reduce that to find out what x is. That's going to be, what, 43 and a third, 43.3 repeating. Okay. And let's just look back up here to make sure I didn't make a mistake somewhere along the way. Outside is 18, whole is the sum of the two. Outside is 23, whole is the sum of the two. And I think as long as we did our math right, we should be good. Okay, I'm going to clear this because the next one's going to take a little more room. So let's go back to ow. And I'm going to be using this circle this time. So starting with the top line, the blue line in this case, what's the outside? X. What is the whole? And what's the outside of the bottom line, the other line? 6. And what's the whole other line? 6. Good. So now I need to multiply through. X times this is going to give me, what's x times x? Is it x squared or 2x? X squared. Good. And x times 5 is 5x equals 36. Okay, can I get x by itself now? Which x would I try to get by itself? Well, if I square root everything, let's just say I did, then I'm going to end up with a square root over this x. Is x really going to be by itself? No. Divide everything by what? If I divide everything by x, then I'm going to end up with an x on the bottom here. I could subtract 5x, and then I'm going to end up with a negative 5x over here. Is x by itself then? Okay, so when we solve for x, we usually want to have x equals something with no x's over here, right? No x's. There's no way to get this x solved using addition, subtraction, multiplication, division like we normally do. This is not a linear equation. This is a quadratic, and therefore we have to go back to our quadratic techniques from chapter 9-ish, 10-ish, somewhere in there in Algebra 1. We have to factor. You guys remember factoring? Okay, so we're going to go through and we're going to factor this. So let me get rid of this. And the first thing we need to do is we always need to move everything to the same side and have a 0 on the other side. What do I need to move to get everything on the same side? Subtract 36 from both sides. So what am I going to get? X squared plus 5x minus 36 is what? Trying to trick you. What's 5x minus 36? Good job. 5x minus 36, right. Okay, you cannot subtract those. All right, so x squared plus 5x minus 36 equals 0. Does anybody, is this starting to ring a bell to anybody? Does remember, kind of remember these? Okay, so I'm going to move this up here so we can see it a little bit. X squared plus 5x minus 36 equals 0. Now, what we found out when we used to do these is that there exists two parenthesis binomials that multiply together to give me this, if it's factorable. Now, we're not sure that it is factorable, but if it is factorable, there exists two binomials that we can multiply together. Now, did your teachers teach you FOIL? F-O-I-L. Okay, or distribution. It's also called distribution. But when you did FOIL, you started with first times first. So what had to go in those positions to give me x squared? X times x. Okay, so next we had to do outside and then inside, and those always went together. And then we did last, which would be just number times number. So what two numbers could I multiply together to give me the last term? Negative 36. Okay, so I heard a couple different options. Let's test these options out. So if I start over here with negative 36, 1 times 36. What else? 2 times, what's half of 36? 18. Guys, I don't think that you guys remember this well enough to be goofing off while we're doing this. 2 times 18. What else do we do? 3 times 12. What else? 4 times 9 and 6 times 6. There's a lot of options there. Now, how did they become negative? How did this become a negative 36? One of them has to be negative. Does it matter if the 1 or the 36 is negative? They both end up with a negative 36. So we need to remember that either one of these could be negative. Either the first one or the second one. We're going to see which one helps us the most, okay? So now, if I used 1 and 36 and I put them here, 1 and 36, what do I get when I do outside? I get 36x. And inside is going to give me 1x. Will 36x and 1x add or subtract to give me a 5x? No. So 36 and 1 are probably not the answers, right? I don't need to go through the trouble of plugging them in. Let's just look at them over here and see what happens. Could I add or subtract 36 and 1 to get 5? No. How about 18 and 2? No, they add to be 20. They subtract to be 16. 12 and 3. No. 4 and 9. Okay, well, what about 6 and 6? So the only way I could even possibly get 5 is with 4 and 9. Now the question is, let me erase, get rid of that, and that. If I use 4 and 9, one of them has to be negative to give me a negative 36. Which one needs to be negative so that they come up with a positive 5? Do I want to have 4 minus 9 where the 9 is negative? Or do I want to have 9 minus 4? So if I have a negative with the 4 and a positive with the 9, let's check this out. I'm going to get x times x. That's first times first. I'm going to get positive 9 times x. I'm going to get negative 4, so this will be negative 4 times x. And then I'm going to get negative 4 times 9. So what's x times x? X squared. What's 9 times x? 9x minus 4x. What is 9x minus 4x? What do those go together to be? What's 9x minus 4x? 5x. And negative 4 times 9? Negative 36. Did we get back to where we wanted? X squared, 5x, and a negative 36? Yes. So this is the correct factoring. This is called the old Hunt and Peck method. We're kind of just testing things that could work and see until we get to the right answer. There's some other trick ways of doing it, like the box method, the diamond method. I'm not sure. I've done a few of them. I prefer this method myself, just because you get to know the numbers a lot better. Okay. How does this help me? I now have two binomials that multiply together to give me 0. Let's get away from this for a second. If I told you that you had a times b equals 0, what would you tell me? What do you know for sure about that scenario? Okay, that's right. A times b does equal 0, but what does one of the numbers have to be? If I had 3 times 2, does that give me 0? What's the only number I can multiply 3 by to get to 0? 0. Does it matter what number I put in place of 3? Negative 12 times 0. 246 billion times 0. The only way to multiply and get to 0 is through 0. So we know that either A or B has to be 0. And if that's true, then I know that either this has to be 0 or this has to be 0, or possibly both of them are 0, right? 0 times 0 is also 0. So since that's true, I'm going to separate them and put the letters OR between them and say, look, either x minus 4 is equal to 0 or x plus 9 is equal to 0. That's the only two possibilities where you could get 0 for that answer. So now I can solve these. Add 4 to both sides, and I'm going to get x equals 4 or x equals negative 9. Looking at this problem, can x be 4 in this problem up here? Can this number be 4? Does that sound like a normal number for x? Okay, it does. What about negative 9? Could x be a negative 9? Can I have a negative 9 length? No. So the only possibility is that x equals 4. The negative 9 can be thrown away, and that is our answer. Thank you, guys.